Hi, I'm John with the FuTech Technical Support Team, and in this video we're going to be going over how to set up the IAA series amplifier to your sensor. The IAA amplifier can be set up through a live calibration with known loads, or it can be set up using a simulated load using shunt resistance. In this video, we're going to start by doing a live calibration. For the calibration, you will need to know the following. Number 1. Sensor spec sheet with wiring. FuTech sensor spec sheets can be found online by typing in the sensor's part number or model number into the search window of the FuTech website. After your sensor has been found on the FuTech website, click on the blue spec sheet link to obtain the spec sheet with wiring information. Number 2, your sensor's millivolt per volt output. The millivolt per volt rated output is an electrical measure of the sensor while under load and can be found on the sensor's calibration certificate. Calibration information can also be found on the FuTech website by entering the sensor serial number into the FuTech online calibration summary database. Number 3, the amount of load to be used. If the load used in calibrating the IAA is not the full load that will represent the full output from the IAA, then the percentage being used should be calculated as a percentage of the full load that would generate the full output from the IAA amplifier. This will help determine what the voltage output should be for the applied load. For example, an IAA 100 amplifier that will have its full 10 volt output with a sensor loaded to 100 pounds would produce 7 volts if the load being used in the setup was 70% of the full range output, or 70 pounds. Number 4, excitation from IAA amplifier. The IAA amplifier offers 10 volt excitation and 5 volt excitation. The sensor spec sheet will specify the max voltage the sensor can be excited with. When possible, use a higher excitation, as this means less gain will be needed and help reduce noise. Number 5, desired output range from IAA amplifier. The IAA amplifier offers a standard output range or an offset range where the 0 is shifted to the middle of the positive output. The IAA 100 offers a plus or minus 10 volts or plus or minus 5 volt standard output range and a offset range of 0 to 10 volts with the 0 output at 5 volts. The IAA 200 offers a standard 4 to 20 milliamp output and an offset range of 4 to 20 milliamps with the 0 output at 12 milliamps. Number 6, gain level and dip switch settings. The output from the amplifier is a product of the sensor's millivolt per volt output, excitation level, and gain level. An online Excel sheet is available to assist in determining the gain needed and the dip switch configuration for the needed gain level. In the gain Excel sheet, there are 2 worksheets. The gain dip switch configuration worksheet can be used to determine the dip switch positions on the gain dip switch. In the Excel sheet, choose the excitation level to use from the drop-down list. Next, list your sensor's millivolt per volt in the output box. The lower and upper limit is not the full output range, for example 0 to 10 volts. The lower and upper limit represent the output range when the sensor is fully loaded. Rows that are highlighted are the rows that will meet the entered information. Note, if using the offset feature, you'll want to double the amount for millivolt per volt. Half the normal amount of gain will be needed, as the 0 output will be shifted to the middle of the positive output range. After the gain dip switch configuration has been identified, set the gain dip switch accordingly. With the power first off, make all connections to the amplifier from the sensor, instrument, and power supply. Utilize the sensor spec sheet to confirm sensor connections. After all connections are confirmed, apply power to the IAA amplifier. With no load on the sensor, adjust the zero output level using the zero potentiometer as close to the zero output level as possible. If the offset feature is used, the zero will be the middle of your positive output range. Next, place the known load onto the sensor and adjust the output to as close to where it should be for the applied load using the span potentiometer. Remove the load and reconfirm the zero output, adjusting if necessary. Next, reapply the known load and reconfirm the output under load, adjusting if necessary. Repeat several times as needed until the zero and output under load are as close to where they should be as possible. Shunt. Shunting is simulating a load on a sensor by offsetting the internal resistance of the sensor through the use of an external resistance between the sensor's negative signal output and negative excitation wires. Shunt can be used to help calibrate the sensor to the amplifier and can be a tool to confirm the operation of the sensor. During normal loading conditions, the shunt is not used. During a sensor calibration, a shunt will be performed at FUTech, and the results of the shunt, as well as the resistance used, will be listed on the calibration certificate. For the IAA amplifier, the shunt is activated by the shunt push button or through the remote shunt line, which is activated when power is applied. The IAA amplifier offers an onboard dip switch control for shunting with multiple shunt resistance levels. The IAA gain setting Excel sheet can be used to set the resistance for the shunt. In the gain setting Excel sheet, the second worksheet at the bottom, Shunt Dip Switch Configuration, is used to determine the dip switch configurations. Choose the excitation level from the drop list for the excitation row. For bridge resistance, measure the resistance on the sensor between the negative signal output wire and the negative excitation wire. The measured resistance will be used in the bridge resistance row. For the gain row, enter the gain amount used from the selected row in the gain dip switch configuration worksheet. The lower and upper limit rows represent the resulting calculated shunt output ranges. The resulting yellow rows are shunt dip switch combinations that will result in an output between the lower and upper limit. The output column will specify the output the shunt resistance should generate. The combined resistance column will specify the resulting shunt resistance level. For further IAA support, please see the IAA support page on the FUTech website. For further support, contact FUTech at 949-465-0900 or FUTech@futech.com.